السلام عليكم جميعا، بتمنى تكونوا كلكم بصحة وخير وسلامة، وبنتمنى أكيد الفرج العاجل والنصر القريب يا رب. This is part 2 of craniofacial growth. Craniofacial growth is a very dense subject actually، فعشان هيك اضطرينا إنه إحنا نقسمه لأكثر من محاضرة. بس زي كل التوبكس بالتقويم هي بتحتاج فهم أكثر من ما إنها حفظ. So hopefully this lecture will be easy and understandable for you. In this lecture, we're going to talk about growth pattern and the cephalocaudal gradient, about fetal head and birth. We're going to talk about growth variation and timing, mechanisms of growth at the cellular and tissue levels, nature of bone formation, the endochondral ossification and intramembranous ossification, bone remodeling and displacement, growth of the skull and the facial bones. In this lecture, we're going to discuss the cranial vault only, and we're going to talk about craniosynostosis. Again and again بنذكر why is it important for us to understand growth. When we understand growth, we can distinguish between normal growth and an abnormal growth in a child. And hence, as healthcare practitioners, we can be of great benefit to notify the parents, to refer them to the correct specialist, نحكي لهم إنه في إشي غلط. Okay? Number two, that we as dentists and especially as orthodontists actually can modify the entire dentofacial complex with our treatment. And so it is important for us to know how we can modify it in a favorable way and avoid any treatments that can actually have unfavorable effects on the growth or on the face. في عنا 3 مفاهيم عن الجروث رح نمشي فيهم واحدة واحدة. growth pattern, growth variation and growth timing. growth pattern أو نمط النمو، من اسم الكلمة نمط أو pattern معناتها إشي عم بيتكرر، كيف قطعة القماش اللي بنحكي عليها pattern معين مثلا مقلمة أو إشي زي هيك. So normal growth has the same pattern in all humans, in everyone. Okay, and we will discuss one of the normal patterns for growth in the next slide. However, there is variation in the amount of growth because not all humans reach the same height or the same weight. So there is variation in that within normal limits, and there's also variation in timing because not everything happens for everyone at the same time. تعرف في ناس تبلغ في عمر 13، في ناس تبلغ على عمر 15. So we will also discuss that in the next slides. So one of the patterns of human growth is the cephalocaudal gradient of growth. Cephalocaudal, that means cephalo from the brain region to caudal يعني tail region, from head to toe, من فوق لتحت. Okay? The cephalocaudal gradient follows the fact that first of all the rate of growth near the brain is the highest and is the lowest as we go down. Okay, from high to low. During intrauterine life, the head is about تقريبا زي ما انتم شايفين بالصورة هون half of the total body. Okay, and the limbs and the rest of the trunk is rudimentary and small. And then rate of growth in these areas starts to increase so that by the time of birth, you can see that the head now makes up about 25 to 30% of the total body. Okay, and the limbs have grown. As the child grows, the overall pattern follows this course, and we can see progressive reduction in the proportion of the head to the rest of the body until by adult life it's almost 12% of the entire body. This shift of growth زي ما حكينا اسمه cephalocaudal gradient, and it simply means there is an axis of increased growth extending from the brain toward the feet. What does the cephalocaudal gradient also mean? It means that there is more growth of the lower limbs than the upper limbs during postnatal life. يعني بنشوف بالأخير إنه بعد ما ينولد الطفل يمكن الإيدين والرجلين بيكونوا مقارنين بأطوالهم مع بعض. But as we grow more, the lower limbs will grow further. Also, the face will grow later than the cranium because it's further from the brain, and the mandible being further away will grow more and later than the maxilla. طبعا كل إشي له حكمة من ربنا. Here we can compare the skulls at birth and the skull of an adult, and you can see that there is big difference in the lower jaw, and the relative lack of growth of the lower jaw prenatally It's very important to make birth and passage of the skull through the birth canal much easier. Here we can see growth patterns for different tissue systems within the body. Of course زي ما حكينا the patterns are the same for all humans. يمكن التوقيت تاعهم يختلف شوي بس every system and every normal growth follows the same pattern for every human. يعني ممكن نقدر نطلع على الجنرال tissues of the body اللي هم muscle, bone and viscera. They follow an S-shaped curve. At birth there is an acceleration and then before خلينا نحكي in the early years of childhood there's some deceleration or slowing down, and then around puberty and the pubertal growth spurt there's an acceleration again, and then it slows down again reaching to adult life. So it follows an S shape for everyone if they are going through normal growth. The genitals are usually slow and then they accelerate around puberty. Neural, however, there is acceleration during early life and then it slows down and reaches a plateau. And for lymphoid tissue system, it's usually very high during the early years of life, reaching for around 10 years, and it also grows far beyond the adult sizes. And then we can see that there is a slowing down of the growth and actually involution or reduction in the size until it reaches its adult size. These patterns are usually predictable. Okay, this is what's important about patterns, is that you can expect that they follow these curves. هلا نيجي للgrowth variation اللي احنا بالعادة بنطلع عليه by comparing or looking at a growth chart. These growth charts are derived from studying a large number of children, okay, that represent normal variability. يعني احنا بنعرف انه لما نيجي نطلع على مجموعة من الأطفال كلهم عمرهم 5 سنين ما رح يكونوا كلهم نفس الطول، ما رح يكونوا كلهم نفس الوزن، رح يختلفوا ويكون في فروقات بيناتهم بس طبعا within normal limits. اوكي، هون في عنا ال 50% percentile اللي هي بيكون فيها الافريج بالعادة، وهون في عنا الماكسيمم ليميت وهون عنا المينيمم ليميت. يعني لو لقينا طفل عمره 5 سنين وطوله مثلا 50 سنتي بنعرف انه هو مش within هاي النورمال ليميتس وفي اشي غلط. الجروث تشارت بالعادة معمولين للستاتشر او الهايت وللويدث، وفي طريقتين حتى نقدر نشوف إذا الطفل normal or not. الطريقة الأولى is that we can compare a child to his peers at the same age. يعني for instance بنقدر نيجي لطفل عمره 6 سنين نقيس وزنه ونقيس طوله ونحطهم على الجراف ونشوف. يعني مثلا هذا الطفل اللي بالأخضر هون بنقدر نشوف إنه بالنسبة لطوله هو جاي average على 50%. أوكي، بينما مثلا بالنسبة لوزنه جاي على 75%, but still within normal limits. هلا the general guideline is that a child who falls beyond the range of 97%, يعني على extremes على ال 3% extreme, whether على high or على low percentiles, they should receive special study before being accepted as just an extreme of the normal population. والطريقة الثانية is that we can follow a child over time to evaluate whether there is an unexpected deviation from the usual growth pattern. يعني هذا الchild هون you can see إن أوليتها من عمر 6 سنين بلش يسجل مثلا الطبيب تبعه طوله ووزنه و he was following the normal pattern, and then suddenly he's not following that pattern and he's falling behind it, and that means إنه something wrong has happened here. So again, this growth chart helped us to compare if هذا الدروب كان normal بالنسبة للpattern ولا لا, and it definitely shows not, because the pattern here is still accelerating for the other kids. Coming to growth timing, زي ما حكينا, the time that things happen for different individuals happen at different times. So this is why a lot of times you hear of something called biologic age instead of just chronologic age. The chronologic age is the age that we count for a human since the day they are born. So they are 5 years, 6 years, just counting the time since birth. However, biologic time is the time of the biology of that certain humans, organ systems and tissues and their maturation rate and the onset of events happening inside their body. So biologic age is different. It's more developmental than just counting days since birth. هلا so far all the charts اللي كنا عم نطلع عليهم كان اسمهم distance curves اللي هم زي هذا اللاين الأسود اللي هون اللي هو إحنا we are measuring let's say the height okay according to the age and then we are just plotting height at each age okay قديش طول المريض على عمر السنتين على 4 على 6 8 following that up until let's say here the age is 18 so this shows you that the height is increasing from birth until the patient was 18. This is the distance curve. However, there is something called a velocity curve, which shows you the rate of growth and not the amount. So here you can see that at birth the rate was high and then the rate was dropping. زي ما حكينا بالearly years of childhood, the rate drops and then becomes نوعا ما قليل, and then look here, the rate of growth suddenly goes into a high spike, and this is around the age of puberty. So a velocity curve shows us the plotting of the rate of growth against time, and this gives us an indication متى في عنا spurts بالgrowth زي the one around puberty. So this is a velocity chart for 3 different girls. Okay, you can see that the rate of growth follows the same pattern for all 3. However, it does not happen at the same age for them. So this girl, M1, she had her menstruation or menarche early around the age of 11. The second one had it around the age of 13, and the third one had it late around the age of 14, 14 and a half. Okay, so you can see how the rate of growth spikes right before each girl gets her menstrual cycle for the first time. And you can see the different timing for every girl. So why does that matter? ليش عم نطلع كلنا على growth variation and timing? Because the success and optimum timing of orthodontic treatment is usually much higher when we provide it at an age that is more suitable for that patient's own developmental age rather than just their chronologic age. For instance, some patients, they will have their maturation and their puberty spurt at around the age of 13 in girls. So we have to start our treatment earlier. But in males, it's around the age of 15, so we have to start it a little bit later. And you will have a whole new lecture about growth modification later on, inshallah. Okay, so going to the mechanisms of growth مراجعة سريعة لأنه already أنتوا بتعرفوا هاي الأشياء from your previous histology and physiology courses. At the cellular level, cells are capable of growing by increasing in their size of individual cells or increasing in number of cells or secretion of extracellular matrix. When we come particularly to skeletal growth, the most important mechanisms are hyperplasia, and which is more important is the secretion of extracellular matrix that becomes mineralized later on. Hypertrophy happens, but to a much lesser and less significant degree. Now zooming out at the tissue level, these 3 mechanisms of growth اللي هم hypertrophy, hyperplasia and secretion of matrix can either happen at all points across the tissue, like what happens in all soft tissues. All points can experience the hypertrophy, the hyperplasia and the secretion of matrix, and this is called interstitial growth. Or in the case of tissue that has already mineralized like bone, it is no longer able to grow at different points within the tissue. There is only capacity to add new cells and cells to enlarge and to secrete matrix only at the surface, and this is called direct or surface apposition. So what mechanisms exactly contribute to skeletal growth? Is it only surface apposition, or does interstitial growth also contribute to the growth of the skeleton? As we said, in mineralized bone, the activity of cells in the periosteum, which is the soft tissue membrane that covers the bone, allows surface apposition to existing bone through both the formation of new cells and secretion of extracellular material that gets mineralized and becomes new bone. However, interstitial growth is also a prominent aspect of overall skeletal growth, not of bone formation, but of skeletal growth, because a major portion of the skeletal system is originally modeled in cartilage, which is called ossification. رح نحكي عنها كمان شوي، اللي هو we are ossifying or mineralizing existing cartilage, and that cartilage already grows by interstitial growth. An example of that is the cranial base and the trunks and the limbs. How does bone form to begin with? Bone can form in two ways. One, endochondral ossification, which is the mineralizing or the bony replacement of a cartilage model that already exists, or by intramembranous ossification, which is the formation of bone directly within a mesenchymal membrane without any cartilaginous model that precedes that. So مراجعة سريعة على حكي already انتوا بتعرفوه. endochondral ossification, the cartilage model becomes replaced by the bone. بصير عنا proliferation أول إشي بالcartilaginous cells, and then they get ossified or mineralized. Okay, the cartilage itself زي ما حكينا can grow interstitially, but once it's mineralized, that's it. Okay, بدنا نعرف إنه not all bones of the adult skeleton are replaced or represented by embryonic cartilaginous model. It is possible for bone to form by secretion of the matrix directly within connective tissues without any intermediate formation of cartilage. However, once mature, the bone for both endoosseous or intramembranous is the same. You cannot differentiate it. A single bone أصلا may be formed by both intramembranous and interchondral ossification, and later on these parts fuse and merge and you cannot distinguish them. So this is a quick revision of the histology. These are histologic sections, and you remember how it was. There is a cartilage plate and that produces a lot of cells. There is a high rate of proliferation here, and as these cells increase in number, they get pushed here. They secrete extracellular matrix that becomes mineralized, and then we can see zones of ossified centers within the cartilage, and these zones fuse, eventually making up the bone. Okay, so the amount of cartilage increases, but the relative amount of cartilage decreases as ossification happens. In long bones, تتذكروا الepiphyseal plate, and growth is happening in both directions, and because the cartilage grows by interstitial growth, then interstitial growth of the cartilage is the main reason of increase in length in these bones, and then these cells get calcified and mineralized. Okay, toward the end of normal growth, the rate of maturation or calcification here exceeds the rate of proliferation of the cells here. Okay, and the last of the cartilage is then replaced by bone, and the epiphyseal plate disappears completely, except the remaining growth, or خلينا نحكي remodeling of the bone, is just surface changes in thickness due to the periosteum. طبعا إحنا we are more concerned of the craniofacial bones, or the bones of the skull and face, craniofacial, rather than the long bones of the body, and this is why we divide them into 4 structures عشان يسهل علينا how to study them. Okay, في عنا the cranial vault, which is the bones that cover the upper and outer surface of the brain. Okay, and then we have the cranial base, this one, and it is the floor, the bony floor under the brain, and also divides between the cranium and the face. And then when we come to the face, we have the nasomaxillary complex that has the nose, the maxilla, and small associated bones like the temporal bone and the zygomatic bone. And then we have the mandible. So from the craniofacial complex, most of the bones, they form by intramembranous ossification. The vault, the facial bones, the maxilla, mandible, even the clavicles. Okay, the only one that grows by endochondral ossification is the cranial base. And of course, we know all other bones of the skeleton grow by endochondral ossification. طبعا there are other terms you must be familiar with before we move on with growth, اللي هم bone remodeling and displacement. We all know that bone is capable of constantly changing its shape, and that is because of surface activity, or خلينا نحكي bone resorption on one side and bone addition on the other side. Okay, and all bones go through this and they react to dynamics and react to pressure by the remodeling. And we have to know that sometimes this resorption and addition can also give the illusion that the bone is drifting or changing position in relation to other structures in the body. So, and this is called displacement. So both remodeling and displacement can occur in the same bone at the same time, but the relative contribution of each is difficult to determine. إذا مراجعة سريعة حكينا البون either forms in cartilage or forms in a membrane, so it's either forms by endochondral ossification or by intramembranous ossification. And the cartilage itself can grow interstitially, but once bone is mineralized, or in the case of intramembranous bone formation, it only grows by surface deposition. Okay, once the bone is formed, then it is always capable of changing its shape in reaction to stresses around it, and that is called remodeling. And sometimes this remodeling can give the illusion that the bone is changing its position, and we will see how that happens when we talk in the next lecture about the maxilla. Okay, and this is called displacement. So starting with the bones of the craniofacial complex, today in this lecture we're going to talk about the cranial vault or the clavarium. Okay, and as we said, it forms by intramembranous ossification, and around week 8 of intrauterine life, these ossification centers begin to form, and then bone continues to form until these flat bones reach each other, and then sutures form in between. The flat bones of the cranial vault occur in pairs, like we know في عنا الparietal bone, temporal, occipital, and we have the frontal bone. So as we said, where the bones developed and grow until they meet, we have sutures. And in areas we have more than one bone meet, we have what we call fontanelles, which are loose connective tissue areas. And these fontanelles are very important for birth so that the skull can squeeze itself coming out of the birth canal. We have 6 of them. We have the anterior, the posterior one, and we have the sphenoid and mastoid 2 on each side. Okay, after birth, of course, the bone apposition at these fontanelles will continue until they are almost eliminated by the age of a year and a half or 18 months. However, the sutures remain, and there continues to be periosteum-lined sutures in between these bones, and the apposition at these sutures remain, and it is the major mechanism for growth of the cranial vault. What is important for us to understand is that the growth of the cranial vault is responsive to the growth of the brain. After all, the cranial vault is the case or the bony case covering the brain. So, as the brain grows bigger, it creates pressure that pushes these flat bones away from each other, and this tension that is separating these bones from each other allows the sutures to deposit more bone at these sutures, and there is more sutural growth. Also, we have to know that there is also remodeling where bone is removed from the inside and added on the outside, and this allows for continued contour changes during growth. Here we see a photograph of a baby that just got born, And as we can see, the skull is quite deformed here, taking the shape of a tube so that it can pass through the canal. And this is because of the large and calcified fontanelles in the skull. We can also see how the mandible is small, and this is all to help the birth of the fetus through the birth canal. So the fontanelles close by the age of 18 months, and the sutures continue to deposit bone alongside their borders until around the age of 7, when the size of the skull, the mature size, is almost attained. These sutures throughout life they continue to intertwine زي ما بتشوفوا هون بتلاقيهم بصيروا يدخلوا ببعض وهذا بنسميه fusion of sutures until these bones are no longer separable. This is important عشان لما نيجي نحكي عن باقي structures within the skull we know which structures we can modify before the sutures fuse and which we cannot after the sutures already fuse. Now, craniosynostosis, this is a whole phenomena or a condition characterized by premature fusion of one or more cranial sutures. This is due to problems that arise during the final stages of facial development in the fetal life, and early closure of these sutures, they can restrict the growth of the skull in certain directions and lead to characteristic distortions depending on the location of these fusions. So craniosynostosis comprises a whole array of distortions in the skull, and these range from a single suture fusion to a double suture fusion to a complex multi-suture fusion. And these are, of course, important to be detected early on in life and receive surgical intervention to release these sutures that have fused prematurely, because they will hinder the growth of the skull in certain directions. These photos are for you to just understand and take a look. You don't have to memorize them. But for instance, you can see that early fusion here in the mid-sagittal suture here, it prevented the skull from growing in the lateral dimension. And so you can see the skull is abnormally elongated and narrow. We've come to the end of the second part of craniofacial growth. I hope it was easy for you to understand. There's a lot of revision of concepts of growth that you already should be familiar with and know from your previous courses. If you have any questions, please let me know, and best of luck.